high sensitivity of 91%, we just detects most instant of rain but results in many false positive. So suitable for scenario where missing a rain prediction is costly. Okay, and higher threshold is 0.4, and here we have specificity of 91%. That is minimize false positive but increase false negative. So useful when false positive are more determinant than missing rain prediction. So these outliers may need special treatment through clipping or removal or transformation. Okay. Whenever you just have this described, first of all, of course, I have already specified. First, go on towards the count. The count, it just shows how many missing data it just has. And next, it is all about the central tendency as like a mean and median value, and kindly have a view on towards the minimum and maximum data. And whenever you are just looking on towards data, if it is a minimum, if it starts with 0, be aware whether that exact 0 is the data or it is specified as like a empty. And of course, skewness indicates that need of transformation. And of course, dear friends, we can just go for log or box cost transformation. Okay, so the model accuracy here we just get 85%, and here the null accuracy we just get is 78%. Okay, so the model significantly outperforms the null accuracy, confirming its predictive strength. So this means it is not just relying on majority class prediction, but effectively capturing pattern in the data. And here, dear friends, the models nearly misses half the actual rain prediction of 0.59. Okay, and this weighted average F1 score we just get 0.84, suggests that model is generally balanced but biased towards predicting no rain. And dear friends, here the logistic model is now equipped to predict whether it will rain tomorrow based on the Australian weather data. And here the pre-processing step we have followed is yes, outlier capping done, encoding categorical variable, and feature scaling ensures robust prediction. And dear friends, the model prediction probabilities can be used to determine confidence in each prediction. Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to explore one of the most fundamental algorithm in machine learning, that is logistic regression. In this session, I will guide you through building a logistic regression classifier using Python, and which is to predict whether it will rain tomorrow in Australia. Dear friends, whether you are a beginner or just brushing up on your knowledge, this step-by-step tutorial is tailored for you. Okay, first let's get the basic, right? Okay, logistic regression is a powerful classification algorithm that's commonly used to solve problems where the outcome is discrete. So meaning we are predicting categories. Difference, it can be as like an example, will it rain tomorrow, yes or no? Or if you are receiving an email, whether it is a spam, yes or not a spam. Or will a customer buy the product, buy or not buy? So it's an incredibly effective choice for binary classification tasks like this. But it also adaptable for more complex problems using multinomial or ordinal logistic regression, which we will cover shortly. Okay, now that we understand what it does, okay, let's look how it works, that is logistic regression works. Difference, at its core, logistic regression builds a linear equation based on the independent variable. Think of it like drawing a straight line, just like we do in linear regression. But instead of directly using this line to predict the outcome, logistic regression applies a mathematical function called sigmoid function to the result. And here's how the linear equation is represented. Dear friends, if we are having that mathematically, which we have only one exploratory variable and one response variable. So kindly just observe. Okay, z is equals beta naught plus beta 1 times x1. And here the coefficient beta 0 and beta 1 are the parameters of the model. And if we have multiple exploratory variables, and yes, the linear equation is represented as z equals beta naught plus beta 1 times x1 plus beta 2 times x2 and so on up to beta n times xn. Dear friends, this is the linear combination of the input feature. And beta 0, beta 1, 2 until beta n are the model coefficient. And here x1, x2 till xn represents the input feature. We have the linear combination. We pass it through the sigmoid function to squash the output between 0 and 1. This is exactly crucial because we are predicting probabilities. Dear friends, the sigmoid function is given by the formula, that is sigmoid 0 equals 1 divided by 1 plus e to the power of negative z. And here this sigma z, yes, is the predicted probability of a positive class or class 1, whatever you can just specify. And here this e, yes, is the Euler's number, approximately 2.718. And here the az is the linear combination we just calculated. And dear friends, the output will always be between 0 and 1, representing the probability that a particular observation belongs to class 1 or a positive class. Once we have the probability, yes, we apply a simple rule to decide the class, that is decision boundary. And here we have, of course, a decision boundary. Let me just set it as like 0.5, so that if the p, the probability that is greater than or equal to 0.5, yes, it belongs to class 1. Or if the exact probability is less than 0.5, then it belongs to class 0. So you can think of it as a line separating the two classes. And dear friends, here I just specify a small example. If the predicted probability is 0.8, it means an 80% chance of rain, or a class 1, it depends on to the data. And if the predicted probability is 0.3, it means a 30% chance of rain. So where it just goes towards class 0. So, and that's the beauty of logistic regression. It's simple, interpretable and effective of classification task. And before we start building the model, yes, it's essential to understand its assumption. And here are the key assumptions to keep it in mind. The first one, of course, about the target. So binary or categorical target variable. Different logistic regressions works best when the target variable is binary as like yes or no, or categorical as like yeah, you can just have spam or not spam, like that. And it's an independent observation. Yes, the observation must be independent, meaning no repeated measurements. And next, it's on no multicollinearity. Yes, dear friends, independent variables should not be highly correlated with each other. Next, the linearity of log odds. Difference, the relationship between the independent variable and the log odds should be linear. And last but not least, the sufficient data. So logistic regression performs well with even it's in a large data set. Okay, now depends on the number of categories in the target variable. Yes, logistic regression can be categorized into three main types. So binary logistic regression, of course, used for two categories as like yes or no, or spam or not spam. And provide an example, that is predicting whether a customer will purchase a product. And when on just going towards multinomial logistic regression, of course, for 3 or more categories, but that have no order. Okay, so example, classifying anything as like different fruits, apple or banana or mango, like that. And where it comes towards ordinal logistic regression, yes, which is used when the category are ordered. So as like classifying movie reviews as bad, average, or excellent, or you can just making how, what about the ranking 1, 2 and 3, like that. So yes, dear friends, this is our introduction to logistic regression. Now we will dive into a practical implementation using Python and build a rank prediction model. Okay, so here is the exact necessary libraries I want to include. So NumPy, of course, used for numerical operation, pandas used for data manipulation and analysis, and Matplotlib, PyPlot, and Seaborn, which is used for data visualization. And dear friends, let I just include the warnings also, which is used to ignore unnecessary warnings. And here we have included the exact data set. Yes, this one we have done imported from downloaded from Kaggle. Okay, so it is a CSV. So we have made use of the pandas, which is used to load the data set into a data frame. Okay, now let me explore the data. Dear friends, first of all, let me just review what about the dimension of the data set. Yes, of course, we have 2,59,908 records with 24 columns. Okay, so here let me just have a view of the data frame. So when I'm just providing this df.head, yeah, we have the top 5 records here, okay, which displays the first 5 rows. And yes, the data set contains max temp, rainfall, minimum temp, location, evaporation, sunshine. So of course contains weather related variables. Okay, so yes, dear friends, and when on just watching, of course, as it has so 24 columns, let I just have a view, only the column names. Okay, so here's location, of course, the date, location, minimum temperature, maximum temperature, what about the rainfall, evaporation, sunshine, wind gust direction, wind gust speed, wind direction at 9 a.m., 3 p.m. and wind speed at 9 a.m. and 3 p.m., humidity at 9 a.m., 3 p.m., pressure at 9 a.m. and 3 p.m. and clouds related towards 9 a.m., 3 p.m. and towards the temperature 9 a.m. and 3 p.m. and whether it is rain today or rain tomorrow. And here, of course, here one risk underscore column. Of course, this is not needed as per data description. So let me just remove it, or we just drop it. Okay. So let I just drop the column. Okay, so by using df.drop, we are removing it, and let me just have an info related towards the data set. Okay, so kindly just observe, dear friends, we are having 2,59,908 index, so which is just specifies 0 to 2,59,907 indices, and towards these records, yes, we have 16 numerical variables and 7 categorical variables. Okay, so yes, with this, let me just move on towards the type of variable. And dear friends, in this exact particular section, yes, I will be segregating the data set into 2 main types of variables, as like categorical and numerical. Here, see, now data sets often contains a mix of both, and it's essential to differentiate them for further analysis. Okay, so let me just have the categorical data. So here we go with categorical. Okay, so I just want to have the categorical where the D type is O, which is just refers as like object data type. Okay, and yes, only the object data, we have 7 categorical. Of course, we already know that, we have already viewed it, and let me have the categorical data's alone top 5 rows, and we have extracted. And yes, here kindly just observe, dear friends, where here date, location, wind gust direction, wind direction at 9 a.m., 3 p.m., and here rain today. Of course, these would be our input future, where here rain tomorrow is the target variable. We are predicting if it will rain the next day. So that is what we have to identify or towards the prediction. Okay, now main towards this, yes, here we just go with the summarization which we have already discussed. We have, apart from date variable, we have 6 categorical variable. Okay, why I have just specified date variable? Of course, it is the one which we need the exact, even though it is in object, okay, we have to convert it further towards like date format, date time format. Okay, so 6 other than date variable, we have 6 categorical, and here 2 binary categorical as like rain today and tomorrow, and here rain tomorrow is the target. Okay, so let me just explore the categorical variable. First of all, let me have a view of what about the missing data. And here we go whether we are having any categorical towards missing data. Yes, often so many things are there. And in wind gust, here we have 19,240 missing, and towards wind direction 9 a.m. it is 20,000 plus, and 11,000 plus at 3 p.m. And towards rain today and rain tomorrow, of course, we have 7,959 data. Dear friends, here we have so many missing data. Of course, I think we need some imputation, or of course we have to handle this missing data values. And yes, of course, you can also have categorizing the variables also, even there. See here it is to check whether missing variables are there or not. So by using this ins null, I have just done. And even though you can also have a report like structure where it is printing only the output of about the categorical variable which contains the missing data. Okay, now I just want the frequency count of that categorical variable. Dear friends, I have been on just making towards categorical. Kindly just observe. It is not as like one particular direction. And see here, it comes under wind gust direction, wind direction at 9 a.m. And here we go with 3 p.m. and rain today and rain tomorrow. Dear friends, actually here these are all most common wind direction. And here one among the thing I have to just specify, which is just not listed, it is all about the location. Okay, so location with the highest data representation, and which we just provide this rain today and tomorrow. Yes, this has that occurrence patterns. Okay, now let me just go towards the cardinality. Okay, so about the occurrence. Okay, so cardinality refers to the number of unique values within a categorical variable. So let me have a view. Wow, okay. So kindly just observe, dear friends, this location contains 49 labels. And wind gust direction, wind direction 9 a.m., wind direction 3 p.m. It just has 17 labels. And when coming towards this rain today and tomorrow, we have 3 labels each. So, of course, by this variable, like even this date, each and everything, it is specified here as like a object. So, each and every data here, it would be as like a unique only. Okay. So, don't get confusion with that. So, variable like this date, location, wind get direction, wind direction 9 a.m., wind direction 3 m has high cardinality, while this rain today and tomorrow have low cardinality. Indicating binary or a few categorical labels. Of course, don't worry about here. Even we have just seen that it can also be yes and no, and of course, inclusion of NaN, null variables also. Okay, so that is what it just gives me three labels here. Okay, so let me just go further towards future engineering. Yes, we want to convert one particular date column. Okay, so let me have a view what is the data type. And kindly just observe, dear friends, the data type here, it is object. So yes, the date here, it is in a string. So initially in string format, so it is converted into date time format. Okay, so datetime format by using pd.to underscore datetime. And kindly just observe, dear friends, whenever we just making it as a datetime, we would have three more inclusion of columns. Yes, as like year, month and day. Yes, dear friends, from the phrased date, new columns like year, month, and of course year, month, and day, it would be extracted. Okay, and yes, of course, it is extracted by using this dot dt assessor. Okay, so this help capture temporal trends and seasonality patterns. Okay, let I just have a view, and yeah, this exact data set, it just have the year as like 2008, and towards the month it is all about 12, and here it is the date. Yeah, top 5 we have as the date. Okay, now again let me just have a view of this data set. And kindly just to see here, dear friends, we have three inclusion of columns. So certain months might have more rainfall, and year patterns may indicating climate trends. So that exact thing we are just going to extract it with this date functionality. So we have extracted that year, month and day from the parameter date. So creating year, month and day columns allows the model to learn from those such trends. Okay, so yes, let me just have that, and instead of inclusion this, okay, so we have extracted three columns, so let me just drop that date which it feels as like a redundancy. Okay, so to reduce the redundancy, let me drop that date column. Now let me have a view again about the data set. Yes, here we just go with this. And yes. So here we have the columns, and these are the exact columns which we are able to extract from the data frame. And dear friends, let me explore further. So here the exact observation, again we are just making it with the object type, that is the string type. And kindly just observe, now the date column has been dropped. So we have only the 6 categories as like location, wind guess direction, wind direction 9 a.m., 3 a.m. and rain today and tomorrow. So this exact functionality. Now let me observe what are all the missing values. And kindly observe, dear friends, here still more this exact code would just check the missing values in the category columns, and here variables like wind guess direction, wind direction 9 a.m., 3 a.m., rain today and rain tomorrow have a significant number of missing values. Yes, which may require an imputation. Of course, we are just going with some. Okay, now going on towards the location variable. Okay, so this exact location variable, let me just print what are all the number of labels it has. And of course, we have already observed we have 49 unique, that is distinct labels representing various geographical location. Okay, so with this, yes, we are just going to identify what are all the things. Let me have the unique data here. Okay, so these are the exact location which totally it is of 49 unique variables. And yes, let me have the counts also. So with this functionality, let I just see how many things are there among this 49. Okay, so these are the exact 49 counts. Okay, which we just have Sydney and yeah, all the things, Gold Coast, everything. We have some few numbers of data is that. Okay, fine. Now we are going to apply one hot encoding. We are now able to get it, and kindly just observe. So totally we have 49. Okay, so 49 unique distinct locations we have, and in that totally 48 columns we are in extracted by using this one hot encoding functionalities. One hot encoding, yes, it converts categorical variable into binary columns as like zeros and ones. Of course, here we have true or false. Okay, so by using one hot encoding, we are converting the categorical into binary columns, and of course, we are also going to make it into the other further variables also. So kindly just observe here, Winchester. Okay, so let I just have it is having 17 labels, and towards the 17 labels, okay, so these are the unique, and let me just have a view count, that is a value count on each unique direction here, and again we are going for an one hot encoding. So these are the one which we just have, and if you are in need of that wind guesses, so see here, if I just having specified as like drop first to true, so it just shows only the 16 instead of 17 uniqueness. And when on just making yes, here also we are able to identify how many missing values are that. Okay, and let we just go for wind direction 9 a.m. the same thing. So here we have 17 labels, and extracting only the unique, and checking with the value count. So these are the exact value count, and making an dummies, that is one hot encoding. And once after done, so we are dropping the first most column. Okay, so here we done, and the next column, it is all about wind direction 3 a.m. and here too let I just make it 17 labels, and these are the unique extracted from it, and this is the list of value counts we have, and there we just go with the dummy functionalities. Okay, so each wind direction variable has 17 possible values representing as like a compass direction. So as like north, northeast, northwest, south, southeast, southwest, and here northern, northwest. So like that. And of course, we are need of one more columns. Kindly just observe, this is the missing values which are indicated using NaN variables. Okay, and let me just have a view on towards it. Of course, not only this, let we have a view of rain today and rain tomorrow values too. So here rain today we have 3 labels, and towards unique, kindly just observe no, yes, and NaN, and towards the value count. Okay, so no, it is we have a huge no's. Okay, and on N, that is yes, we have 55,000. Okay, so making it down towards get dummies, that is one hot encoding. Okay, so we are having, that is first drop, so no is dropped, and we have only yes and NaN columns. Okay, so these variables are binaries with yes and no, and representing whether it rained today. The rain tomorrow is all about the target variable. Okay, and kindly just see here, dear friends, this exact functionality why we are making it is, yes, it is the one which is useful for building classification model, mainly which we are here in the today's session as like logistic regression. Okay, so now let we move on to numerical variables. So before that, yes, dear friends, we have a small summarization under the categorical variable in our data set. So yes, we have date variables that represented the date column, which is typically used for a time-based analysis. And next we just gone towards six categorical variables as like location, wind gust direction, wind direction 9 a.m., wind direction 3 p.m. and rain today and tomorrow. So among these, this rain today and tomorrow are binary categorical variable. Okay, so most importantly, rain tomorrow serves as our target variable, so which we will predict using our machine learning model. So that is what we just left over about that exploration. Only rain today, we done it with an functionality. Okay, so now let's proceed with numerical data. And kindly just observe, dear friends, this exact numerical data. Yes, of course, this code identify all numerical variable from the data set by filtering objects that are not an object. Okay, not an object. And here, yes, of course, numerical variables typically represents continuous data. So here, like temperature, or what about the rainfall, or what is the wind speed. Okay, so here temperature as like what is the minimum temperature, maximum temperature, and towards the rainfall. So all these which we have, the data set contains 19 numerical variables. Okay, so including this minimum temperature, maximum temperature, rainfall, and here wind speed and humidity all just comes here, and pressure data, about clouds and temperature, and of course we have just made this year, month and day, that also comes here as numerical data. Okay, so let me just have a view what are all the numerical data we have. And yes, as we have already seen, totally we have 19 columns. Okay, so 19 columns we just got it. So here by head, yeah, it just displays the first 5 rows of this numerical variables for initial inspection. Okay, now let we just move on towards what are all the missing values that are in numerical variables. Okay, so let I just have an isnal functionality. So this identifies how many missing values are present in each numerical column. And yes, dear friends, see, missing data can introduce bias in the model and needs to be handled using imputation techniques. Or of course, if it is not much more necessary, or if it has huge missing, yeah, you can just remove it. So handling missing data, yes, it is very much important, and significant missing values are observed here. Kindly just see here for evaporation, it is so huge, no? 1,48,000, and here sunshine 1,58,000 it's there. Okay, cloud 9 a.m. also 1,17,000, and cloud 3 p.m. it is 1,23,000. Okay, so and variables like year, month and day, it has no missing. Yeah, it's so nice of having it. Among 19, so 16 variables, 16 numerical variables contains missing data. Okay, so let me just have a statistical summary. Of course, this is one I used to have, and which were very much interesting for me. So because whenever we just go for this describe, yes, it generates a summary statistical for all numerical columns. And here, yes, it is used to have, yes, this descriptive statistics provides insight into the distribution and central tendency and spread. The spread mainly about the standard deviation and towards the distribution data. So kindly just have a note, whenever you just have this describe, first of all, of course, I have already specified, first go on towards the count. The count, it just shows how many missing data it just has. And next, it is all about the central tendency as like mean and median value, and kindly have a view on towards the minimum and maximum data. And whenever you are just looking on towards data, if it is a minimum, if it starts with 0, be aware whether that exact 0 is the data or it is specified as like a empty. Okay, it is very much important. Okay, now having us like and summarize. So here minimum temperature, it is just ranging from -9 degree to 34, and maximum temperature, it is -4 to 49. Okay, so here so many things are there, and yes, of course, rainfall has extreme values with maximum 474 indicating possible outliers. Yes, yes. So kindly see here. This is what the highest one, and here also we have pressure of 1042. Okay, so pressure and of course humidity, here it is shows 100 and starting with 0. Okay, so this humidity, it just values appears with normal atmospheric range. Okay, so let me just have a view of outliers. And here, of course, as I have specified viewing, yes, we are going to use this outlier by using an box plots. So rainfall, evaporation, wind speed 9 a.m. and wind speed 3 p.m. only. So kindly just see this exact visualize the presence of outlier in the numerical variable. And mainly the key numerical variable I have just specified as like rainfall, evaporation, wind speed 9 a.m. and 3 p.m. only. Okay, and yes, dear friends, I just scrolling the box plot slowly, and yes, box plot of course highlights data distribution and pinpoint extreme values using interquartile range. And towards this observation, yes, significant outliers are there in rainfall, evaporation. So rainfall, there are so many things. Evaporations is also there, and wind speed 9 a.m. and 3 p.m. are visible. Okay, so these outliers may need special treatment through clipping or removal or transformation. Okay, so let me just have the some insight related towards other functionality. So I just want to check with the histogram, and here we just go with the histogram. So same key variables, I just want to have a view. So rainfall, evaporation, and kindly just see rainfall tomorrow, and evaporation towards rain tomorrow, wind speed, and that is 9 a.m. and 3 p.m. according towards rain tomorrow. Kindly just observe, dear friends. Of course, this exact histogram, it just visualizes the distribution of the variables using this histogram. It just helps whether the variable follows a normal distribution or skewed is observed. And of course, all four variables show skewed distribution with a long tail outliers. So here, here, and of course here also it is an outliers is there. And of course, skewness indicates that need of transformation. And of course, dear friends, we can just go for log or box cost transformation. Okay, let me just have a view, and let me detect what is the exact range of outliers. Okay, so yes, by using IQR, we can identify, that is interquartile range. Yes, we can identify the outlier ranges, and kindly just observe. Here I am just executing, and kindly see here the rainfall outlier ranges. It is, that is whatever the data points that is less than -1.79 or which is greater than 2.4 or observed as like outliers. Okay, so any value that is more than 2.4 is outlier. Okay, now let me just go for the another variable, evaporation. And yes, here it just specifies like -11 degree. Okay, so -11 degree, which is less than -11, so it's specified as like an outlier, and towards greater than 21.2, it is considered as like an outlier. Okay, what about the other key variable? One is wind speed 9 a.m. Yes, here the wind speed 9 a.m. observation, it just gives, less than 29. Okay, so the speed here it is less than 29 kilometer per hour, and the greater than 55 kilometer per hour are outliers. What about the speed at 3 p.m.? Okay, so here minus less than minus 20 kilometer hour and greater than 57 kilometer per hour are detected as outlier. Okay, so these are the things. Okay, now let me just have the assigning, or let me just declare which are all the future vectors and target variable. And of course you all know the rain tomorrow, it is the only target variable here, so we are just going to specify as like a target and removing it from the input future. So here we are having X that contains all the independent futures by dropping the target variable, that is rain tomorrow, from the data set, and this Y contains the dependent variable that is representing the binary classification target, so whether it will rain tomorrow or not. Okay, so here we go. And next, of course, dear friends, the data set, we need to split the data set into training and testing data. And here kindly observe, we have specified test size as is equal to 0.2. So this 0.2, which is just phase, yes, the data set is splitting into training as like 80% and testing as 20%. So subset using train test split function. Okay, and here kindly just observe the random state which is equal to 0 ensures reproducibility. And dear friends, the training data is used to fit the model while the testing data evaluates its performance. And let me just have a view about the training data and testing data size. So here, yes, we have 2,07,926 training set, and here 51,982 records in the test set. Okay, now next we just going for feature engineering, which it just make, yes, the raw data, which it transforms raw data into more meaningful feature, which is to improve the model performance. Okay, so before going on to that, let me just have what is the data type of a training data. And kindly just observe, these are the exact, of course, whenever we just have a categorical variable that is identified as like a data type as O, and which is an object data type. And the numerical data types that is identified, which is other than objects. And here, of course, everything are in float, and here we have year, month and day as like integer. Okay, so yes, so 1, 2, 3, 4 and 5. So yes, dear friends, there are 5 categorical variable and 19 numerical variables are present here. Okay, so this is what we just get it from the data types under training data. Okay, so let me just again we want to split it into the categorical data and towards the numerical data. So here, what are all the categorical data? That is, which is equal to object. So here we have 5 data, 5 categorical variables, and yes, here we just get so 19, remaining 19 numerical variables. Okay, now let me just take one by one. So here we just observe or make a small exploring in the numerical data. Do we have any missing? Yes, of course. Missing data is common problem in data set, dear friends. And yes, when on just making towards this numerical data, yes, we can just go for imputation. Okay, and median imputation for numerical variables and mode imputation for categorical variables, it is often very much used in the concept of handling missing data. And yes, median is used as it is less sensitive to outliers than the mean value. So that is what here we use median. Okay, now let me just move on towards whether any numerical there in testing data. Do we have any missing? Of course it has. Now let we observe the percentage of missing values in the numerical, and we are just going to observe in training data. And so these are the percentage. So 60%, 61% of sunshine is missing. 56% of evaporation is missing. Okay, fine. So now let me just impute for categorical variable, dear friends, as I have already specified. So here category we have just in numerical we have just including median. Okay, so in this inclusion of median, let me just observe once on applying the median functionality. Now let me check again whether do we have any missing. No, we don't. Okay, what about the test data? And of course there also we don't have. Good one. Okay, now let me just go for categorical, and towards categorical we are applying mean. Okay, so even if it is more sensitive towards median, okay, then mean you can just apply. Okay, anyhow, let we have, this is the one, and we are applying a mean functionality. Okay, so this is what the mean functionality we just, and let we apply an imputation. Kindly just observe. Here we are just going to make most frequent value, that is by using the mode functionality we are making it in another data frame. Okay, so this one where it is used as like missing values in categories or replaced using the most frequently values with mode formation. Okay, so now once after this imputation, let me just check the train data. Okay, no missing. Let me check the test data. Okay, no missing. And here final check of whole the training data, final check of whole the testing data. Okay, so yes, we have now, yes dear friends, we done a future selection as like independent variables were separated from the target variable. Then we just gone for data splitting. Just I scroll a little above. So we have done our future selections, and then we just gone for data splitting. So data was split into 80 and 20 ratio for training and testing data. And next we just gone for feature engineering, where variables and were categorized as like categorical and numerical. And towards the missing values, numerical variables and categorical variables, so which we just filled with median imputation and mode imputation. So now the data of course is now clean and ready for further pre-processings like encoding, scaling, and model training. Okay, so let me just move on to that. Okay, now here we want to check with an outliers. Dear friends, the data set contains several numerical variables, so such as rainfall, evaporation, wind speed, and wind speed 9 a.m. and wind speed 3 p.m. Outliers in these columns could distort the model, so reducing its predictive accuracy. So the top coding techniques, kindly just observe, the top coding techniques was applied using the max value functionality. Okay, so to cap extreme values, and kindly dear friends, this ensures that no value exceeds a specific threshold. Okay, so the capping ensures that extreme values of rainfall and wind speed are managed effectively. So let me have the rainfall. Okay, so it is 3.2. And what about the evaporation? So yes, in X train it is 21.8, and to the same X test it is also 20.1. Okay, So the rainfall values now, it just makes it as like 3.2 mm, and evaporation is capped at 21.8 mm. And let me just go for the wind speed. So wind speed, it is 55 to 57 kilometer per hour. Okay, so this is after capping. After capping, so this exact step reduces the influence of rare extreme weathers even on model prediction. So that is what it is very much important. And kindly just observe here, kindly have a look on towards what is the maximum value, and even you can just able to see some capping functionalities here. Okay, so yes, now let me just go for categorical. So the data set has a categorical variable like location, wind wind direction 9 a.m, 3 a.m, and rain today. And of course here again I just specified rain tomorrow is a target variable. And on having a look on towards this, so this is how we are able to view the categorical data only. Now, dear friends, of course, these variables cannot be directly fed into logistic regression model since it works with numerical data. So we need to apply binary encoding. So binary encoding is applied to this rain today variable using category encoder. Okay, so resulting in two columns as like rain today 0 or rain today 1. So for that, let I just include this categorical encoder. Okay, and let I just go with this data, and now let me view the direction. Okay, so here we have applied only for rain today, so rain today 0 and 1. So yes, by using this, it just has two columns as ones and zeros. Okay, so binary encoding happened. And next, of course, by using this, yes, we are in splitted into two columns, making it easier for model to interpret. Okay, so similarly, so let I just make it one hot encoding towards this variables, and kindly just observe what we have totally. And dear friends, of course, this one hot encoding is applied by using this pd.getDummies. Okay, so it is to convert other categorical features into multiple columns representing each category. So when on viewing, kindly see here, these are the exact one hot. So here we got this one hot coding, and similarly after one hot encoding, yes, we have 118 columns, allowing the model to access each category independently. Okay, so here too, let me make use of the rain 0 and rain today 0 and rain today 1 also. Let me just combine it for the test data too. Okay, so now the test data also we have 118 columns. Okay, now dear friends, once after this, we are moving towards feature scaling. Scaling is a crucial step for machine learning algorithm like logistic regression, which are sensitive to the magnitude of input feature. And here we just making use of minimax scaling, which scales all numerical values between 0 and 1 to ensure uniformity and prevent certain features from dominating others. Okay, so let I just execute. These are the training data, and we have 21 columns, and let me just have what are all the columns here, and with that we scale the data. And once on scaling 8, kindly just observe, dear friend, after scaling, here we just go with the functionality. Observe the values which we just see here are standardized between 0 and 1. I just scroll slowly. So see here, every values other than the count, okay? So every values which are all you are able to see are between 0 and 1. For an example, if we just have minimum temperature, it just ranges from 0 to 1, okay? So instead of original temperature scale. And to the same humidity at 9 a.m. kindly just see it is 0 to 1. So these values are also scaled, making them comparable to other future, and of course every futures are now is scaled, that is standardized between 0 to 1. Okay, now let me just move on to model training for using logistic regression. Okay, so logistic regression is a classification algorithm best suited for binary outcomes like predicting whether it will rain or not. Sorry, rain tomorrow. Oh, okay, or not. And here, dear friends, of course, I have included this function for training that logistic regression, and here we have included an linear solver which is used since it is optimized for a small to medium sized data set. Okay, so we are in use towards that, and yes, the let me just fit to the model. Okay, the model has been successfully trained using the scaled and encoded data. And here, dear friends, of course, I have to specify one thing here. Random state 0 ensures reproducibility. Okay, now let me just move on towards predicting the result. Dear friends, after training the model, uses the predict method to exactly predict the rain, yes or no, for the test data. Okay, and let me just execute here, and kindly just observe, dear friends, this exact model, it just provides a probability estimation for both the classes. And here this predict underscore prob, this exact method provides that functionality, and the probability of not 0 and probability of 1. So that is what we are in need. So here probability of getting the output as 0, that is no rain, and this is the exact probability of 1. And kindly observe the exact data. Dear friends, of course we have 0.9089. 0.9089. No, of course highest we have. Okay, so yes, highest confidence of no rain, and 0.3 and 1.6, of course. Okay, so here we just have 0.3 as moderate chance of rain. So the prediction are aligned with probabilities with the value closer to 1 indicating higher confidence. And dear friends, here the logistic model is now equipped to predict whether it will rain tomorrow based on the Australian weather data. And here the pre-processing step we have followed is yes, outlier capping done, encoding categorical variable, and feature scaling ensures robust prediction. And dear friends, the model prediction probabilities can be used to determine confidence in each prediction. Now, once after this, let me just go with the accuracy measurement. Yes, dear friends, accuracy measures the overall correctness of the model by calculating the ratio of correct prediction to the total prediction. And of course, you all know about the formula of accuracy, that is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Okay, so yes, with that, let me just observe the data's accuracy, and here we just get the accuracy as like 85%. And when on just comparing it towards the training and the testing set accuracy, kindly just observe, I just want to specify this is the training accuracy. Yes, here also it just shows 85%. And I just want to, one thing just let you know, dear friends, since both scores are relatively close, Yes, both the scores are relative close. Let me just go for some overfitting underfitting method. Okay, so here for underfitting might still be a minor concern. Okay, so this is why adjusting the regularization parameter C is necessary. So I just want to make vary of it. So before that, kindly just observe both are similarly is that. So let I first of all apply C is equal to 100. Okay, so C is equal to 100. So here, of course, before going on to, I just want to specify this, dear friends. Actually, we are making a regularization adjustment using C parameter, and regularization thing we are using here, it is L2 regularization. That is by default to prevent overfitting by penalizing large coefficient. And one thing, kindly have a note, the regularization strength is controlled using C parameter. Higher the C, less regularization. So lower the C, more regularization. And one thing, if it is a less regularization, it is more flexible model. And if it is more regularization, of course, it would be as like a simpler model. So let I just have this C is equal to 100. Okay, so by using this, let me just observe what is the training score and testing score. Okay, so observe the training and testing here. It is 85.2 and 85.05. Okay, slight improvement in both training and testing accuracy, but nothing much. So kindly see here. This is 19 and here it is 20. That is nothing much more. Okay, so here let me just go for C is equal to 001. Okay, 001 in the sense 0.01. Okay, so let me just apply this now. Once done, let I just, okay, once the model is done, so let me just see the accuracy, and see here it is 84.72 in training and 84.5 in testing. So both score decreased, indicating the model is now underfitting. So the model is too constrained, limiting its ability to learn complex patterns. Okay, so the best performing model used C is equal to 100, offering a balance between bias and variance. Okay, so let me just go with that. And now comparing towards null accuracy. Dear friends, null accuracy refers to the accuracy achieved if the model always predict the majority class, that is predicting no rain for every class. Okay, so let I just have the target Y test. So the null accuracy is calculated with these two values, and it observes 78.38%. Okay, so the model accuracy here we just get 85%, and here the null accuracy we just get is 78%. Okay, so the model significantly outperforms the null accuracy, confirming its predictive strength. So this means it is not just relying on majority class prediction, but effectively capturing pattern in the data. Okay, so yes, let me just move on towards confusion matrix. Of course, dear friends, confusion matrix provides a detailed evaluation by classifying prediction into 4 categories, as like true positive, true negative, false positive, and false negative. Dear friends, here this true positive, it is correctly predicting the rain. True negative, correctly predicting as no rain. And false positive, incorrectly predict rain, which we just specify as like type 1 error. And false negative, incorrectly predict no rain, that is type 2 error. Okay, so here we just observe the exact data. So no rain, that is it is 38,650, and rain predicted correctly, that is true negative, here it is 5,559, and false positive, that is false alarm, and here false negative, missed rain prediction. Here we just get the values. And totally let me just apply it on towards our data frame, and kindly observe this is the heat map which we just get towards this confusion matrix. Once after, yes dear friends, we are just in need of classification report. Yes, the classification reports provides detailed metrics for each class. Okay, so inclusion of this classification report library, let me just have this and observe the precision recall F1 score and towards the support. And here the precision, of course, true positive divided by true positive plus false positive, and the percentage of correct positive prediction. And here towards the positive prediction, we just get there is no rain as 87%. And one thing when on just making it towards this recall, yes, recall, it is the percentage of actual positive cases that were correctly identified. And here F1 score, harmonic mean of precision and recall, giving a balanced measure. And dear friends, kindly just observe, yes, we are here with a functionality, high precision of 87% and 97% of recall indicates excellent performance in predicting no rain. And when on towards lower precision, observe lower precision, it is 73, and lower recall towards 49 indicates that the model struggles to predict rain accurately. And here dear friends, the models nearly misses half the actual rain prediction of 0.59. Okay, and this weighted average F1 score, we just get 0.84, suggests that model is generally balanced but biased towards predicting no rain. Additional evaluation metrics are like classification error. And observe dear friends, this classification error, it just shows 14% of prediction were incorrect. And what is the exact formula here? It is, yes, here it is specified with the true positive, true negative, false positive, false negative. But one simple thing, classification error which is equal to 1 minus accuracy. And here of course you all know that accuracy it is 85.05. So for that only I just evaluated that classification accuracy. So if it is minus that, of course we just get 14.95% of prediction were incorrect. And when going on towards precision and recall, let I just have the calculation of this precision, and let I just go with the recall. Of course we have already done with it. We have discussed this in the classification part. Rather than I just want to go with true positive rate. So true positive rate, of course you all know true positive divided by true positive plus false positive, and kindly observe the true positive here, it is 87.18%. And false positive rate here it is 27.33. So 27% of negative prediction were falsely marked as rain. So this is very much important, we have to think over. And towards specificity, and observe the specificity dear friends. Here specificity here it is evaluated by true negative divided by true negative plus false positive, which it just gives as 72.67%, indicates good performance in predicting no rain. Here, of course, the model achieves a strong 85% accuracy and significantly outperforms the null model. However, imbalance between precision and recall for predicting rain suggests a need for improvement. So potential improvements includes you can just go for class balancing with techniques like SMART, that is synthetic minority oversampling, or you can just go with other algorithms, check with another algorithm, or you can just go adjusting the classification threshold to reduce false negative. Okay, so here let me just adjust the threshold value, and towards here I just want to specify one thing. Kindly just observe. By using this predict probability function that provides the predicted probability for both class 0 and 1, let me just go with the prediction. And here there's class 0 and class 1. It just shows the sample with two values. And here class 0, probability that will not rain tomorrow, and class 1, probability that it will rain tomorrow. So here in such a case, let we have the probability, store the data frame, observe here, this is the data. And kindly just see here, dear friends, this one 90.89%, yes, no rain. 0.091, that is 9% probability of rain. So 90% of probability of no rain and 9% probability of rain. So these are from few things where you can just observe. And dear friends, one thing as I have already specified, if you are need on specifying towards probability, so the class 1, if it is greater than 0.5, yeah, it predicts rain. If it is less than or equal to 0.5, it predicts no rain. So here let me just have it with the functionality. So here it just shows the data. Okay, so this is what we just get the data. Okay, so even you can just make a visualization of histogram, so that that we can able to view the distribution of predicted probabilities. Okay, highly skewed to the left. So most prediction have low probability of rain. So majority of samples prediction no rain, since the probability are concentrated near 0. Yes, so very simple, very few simple prediction, a high chance of rain with probability near 1. So this is what a prediction probability. And yes, dear friend, so the threshold level can be adjusted to control the balance between detecting rain and avoiding false alarm. That is very much important. So let me just go with that, and kindly just observe here. We are just going to have some range of 1 to 5. So let me just adjust the threshold from 1 to 5 or 0.1 to 0.4. Okay, and let me just observe here. So yes, on towards 0.1, the accuracy it is 78%, and false positive it is a number of 8,900, false negative it is 2,400. Okay, so we have a good accuracy of 78%. Okay, so with threshold 0.3, we get 82% of accuracy. Good, fine. And it is 78 here, and here it is 82. And with 0.4, we have 84% of accuracy. And kindly just observe the false positive it is 3,300 and false negative it is 4,700. Okay, so even though kindly just have a look on towards the sensitivity and specificity. Okay, so the threshold, lower the threshold of 0.1. So this is what the 0.1. Okay, so with the high sensitivity of 91%, we just detects most instant of rain, but results in many false positive. So suitable for scenario where missing a rain prediction is costly. Okay, and higher threshold is 0.4, and here we have specificity of 91%. That is, minimize false positive but increase false negative. So useful when false positive are more determinant than missing rain prediction. Okay, so let me just go with one more analysis by using ROC and AUC curve. And dear friends, ROC, of course, receiver operator characteristic curve. So here it just plots true positive rate, that is sensitivity, against false positive rate, that is 1 minus specificity at various threshold. Okay, a well performed model will have the curve closer to the top left corner. So let me just see what is ours. And here kindly just observe the one, how it is. It is as like a straight line. If we are having a curve towards the top, yeah, it seems to be a good model, well performing model. But here, what about our RC? No, here it is just a straight line. And when towards that AUC, that is area under curve, okay, so let me just have that area under curve and we just go with curving functionality. And here it just shows 86%, that indicating strong performance. So the model achieved a AUZ of 86%, so indicating strong performance. Okay, and here we just go with cross validation of AUC, ROC AUC, that is 87%. Okay, so here of course let we apply the five-fold cross validation which was performed to validate model consistency. Okay, so let me just apply that and observe the average cross validation score. I just want to view it. So here the approximations or average cross validation score, we just get 85.16. Dear friends, the model accuracy folds of course was approximately we just got 84, and which is consistent with the initial accuracy score as like 85.16. So here we can just have a conclusion that model generalizes well and is not overfitting. And dear friends, of course, you can just have a hyperparameter optimization by using grid search CV. And here I have just provided you the code. And here kindly just observe, this was used to find the best parameter for a logistic regression model. Okay, after applying hyperparameter optimization with grid search CV. Okay, so let me just observe the combination here, and kindly just see here we just applied L2. Yeah, that is what we applied here. So L2 regularization, and watch about the scoring. Yes, here we just get 85.5. Okay, so here, yeah, comparative. Of course, there is not much slight improvement, but even though observed difference when compared towards the previous. Okay, so 85.0. If it is 85.03 or 02, yeah, it seems to be a slight improvement, but here it is all the things as like the same. Okay, so after tuning the model, didn't achieve any improvement in accuracy, but anyhow, so yes, dear friends, so here we just go with the logistic regression model that we observed here. Yes, effective prediction whether it will rain tomorrow with a high accuracy of 85.01. previously we have just done, and here with hyperparameter we have attained it as like 85.05. and yes, adjusting the threshold that can significantly impact sensitivity and specificity, providing flexibility based on use case. And dear friends, ROC AUC of 85.16 further validation the model's performance. And here of course we have just applied grid search CV, provides a and slight improvement on L2 regularization, ensuring optimized performance. And overall, the model is well calibrated and demonstrates reliable results for wealth prediction. And yeah, that's wrap up our detailed walkthrough for logistic regression and threshold adjustment. So we saw how the model predicts probability and how tuning the threshold impacts our prediction. Remember, in real world application, choosing the right threshold depends on the specific use case, whether you prioritize minimizing false positive or false negative. We also explore how to evaluate model accuracy using metrics like accuracy, sensitivity, specificity, and ROC AUC curve. And if you found this video helpful, don't forget to give it a thumbs up, comment below with your thoughts or questions, and subscribe to stay tuned for more machine learning insights. Until next time, keep exploring, keep coding, and happy learning, dear friends. See you in next video.